How do we calculate triple scalar products? Well, what is a triple scalar product? Well, it's closely related to cross product. A triple scalar product of three vectors u, v, and w is u dotted with the cross product of v and w. So here, if we just look at v cross with w, we just have this and then I hat, j hat, k hat. But then once we do that, when we dot product this with I hat, j hat, and k hat, we get ux, uy, and uz. So we set up these three vectors in a matrix, in a 3x3 matrix, take the determinant, and it'll look like this, with ux, uy, and uz, still a negative sign there, and the determinant of 2x2 matrices. So once you've done some cross products, this should be pretty slight adjustment in order to do this. So let's calculate the triple scalar product of this. So that's saying take the determinant of 3, 0, 7, 3, negative 8, 4, negative 6, negative 7, and 3. So we have 3, 0, and 7 multiplied by these determinants. I see 0 times one of these, so I'm gonna know that I don't even need to bother doing this because it'll all multiply up to 0. So 3, I'm gonna use this one with the 3. So negative 8, that should be an 8. 4, negative 7, and 3. This one would have been 3, 4, negative 6, and 3. And here we have 3, negative 8, negative 6, and negative 7. So let's simplify. 3 times negative 8 times 3 is negative 24. Then we subtract negative 7 times 4, which is negative 28, plus 0, plus 7 times 3 times negative 7 is negative 21, minus negative 6 times negative 8 is positive 48. This simplifies to negative 4, no, plus positive 4. This simplifies to, becomes more negative, so negative 69. Now we're going to multiply those out. So we get 12 minus, these multiply to 483. And that gives us as a final answer, negative 471 is the triple scalar product of these three vectors. Another. These vectors are written as a linear combination of unit vectors. Still works the same way. We still only need to write the coefficients. It is worth noting that you want to double check that these are in the right order. Otherwise, you might get the wrong answer. It would be very rare to have them listed in the wrong order, but it could happen. All right, so we have negative 5 times the first one. We have subtraction, just because the middle term always has subtraction, and then 7, and then 9 times the last one. Now this is going to be 5, 1, negative 5, 7. Oh, that was weird. This is going to be negative 2, 1, negative 4, 7. This will be negative 2, 5, negative 4, negative 5. Okay. So it's supposed to be an equal sign. I don't know what's wrong with this right now. So this is going to be 5 times 7 minus negative 5 times 1. We're subtracting. 7 times negative 2 times 7 minus negative 4 times negative times 1 plus 9 times negative 2 times negative 5 minus negative 4 times 5. Simplify each piece. 40. This will be negative 10. This will be 30. Yeah. This is negative 200. This is positive 70. And this is 270. So negative 200 plus 270 is going to be 70, so our final answer is 140. So that's the triple scalar product. Triple scalar products are used for parallelepipeds. Say that a few times fast. Parallelepiped, parallelepiped, parallelepiped. A solid, a three-dimensional solid, whose faces are all parallelograms. So here's a picture of a sample parallelepiped. All of the faces are parallelograms. Opposite faces are parallel. And also opposite faces are congruent. Cubes and rectangular prisms are special parallelepipeds. They're ones where the angles are all right angles, but that's not necessary for it to be a parallelepiped. And the point of a triple scalar product for our purposes is usually going to be to find the volume of a parallelepiped. The volume of a parallelepiped is given by the triple scalar product of any three adjacent edge vectors. So what I mean by that is if you take this vector and that vector, they are adjacent, and then that. They should all start from the same vertex and go in three directions along the edges. They don't have to be perpendicular, but the triple scalar product will only multiply the perpendicular components, so that's why this will work out the way we want it to. So if we calculate the volume of a parallelepiped with adjacent edges, these, negative 3, negative 2, negative 1, 8, 8, negative 2. It is possible to get a negative answer here, and then we'll just take the absolute value of it. So this is going to be the same thing as negative 3 times the first determinant minus negative 2 times the second determinant plus negative 1 times the third determinant. So the first determinant is 8, negative 2, negative 7, negative 5. The second one is 8, negative 2, negative 5, negative 5. And the third one is 8, 8, negative 5, negative 7. So let's simplify. 8 times negative 5, negative 40, minus negative 7 times negative 2 is positive 14. Here we're doing plus 2. 8 times negative 5 is negative 40, minus, this is a negative 5 times a negative 2. This should be 8 times negative 7 is negative 56, minus negative 5 times 8 is negative 40. Negative 3 times, this becomes negative 54. This becomes negative 50. This becomes addition, so negative 16. Negative 3 times negative 54 is 162. This is negative 100, and this is positive 16. Simplifying further gives us 62 plus 16 So 78 cubic units is the volume of a parallelepiped with these three adjacent edge vectors. Thank you.